So I hope you've seen throughout all of the experiences in this module that perimeter is an idea. The perimeter is a thing. It's the outline, it's the boundary of a two-dimensional shape, something like that. And then we can measure that boundary with a one-dimensional length. We can measure the boundary, the distance around a rectangle, a decagon, even a circle. So what you just experienced was measuring the circumference of a circle using its radius length. Just to kind of highlight that and wrap that up, I'm going to share with you a colleague of mine. His name is Ted Coe, and he created a GeoGebra app. Let me jump to it. There it is. Actually, I have it open twice. He created a GeoGebra app to see that. Let me just orient you to what you have here. You have a circle, and by the way, we can adjust the radius of the circle to make that proportional argument that I was talking about earlier. But for now, I'll leave it at this, and notice that that blue radius length right there is the same as that length right there. So one radius length is that much. I hope you can see that if you took this blue segment out and put it there, it would be the same length. And so, imagine you took the circumference, the boundary around this circle, and unwrapped it into a one-dimensional length, thus getting the perimeter. Watch what happens. When we unwrap that circumference, it is clearly 6 and about a quarter, it's actually 6.28 approximately, radius lengths. Whatever that radius length is, you would say there's 6.28 copies of it in a circumference of a circle. Now, let me wrap it back around, and I want you to get the idea that if we make the circle a different size, that the issue of circumference stays the same, because we're going to now measure this smaller circle, but with a smaller radius. So the radius of this circle should also require 6.28, 2 pi, copies of it to make the circumference. Let's see. Let's unwrap. Oops, I have to get a full arc length though. There it is, about there. Okay, if I unwrap, watch, here it comes. Here it comes. Yeah, I don't know why it's so goofy like that. But you can see it. 1, 2, 3, 4, 5, 6 and a quarter. 6.28, 2 pi. There are 2 pi copies of a radius in a circumference of any circle, of its radius, because there's that proportionality there. Small circles have small radius, still 6.28 copies. Big circles have big radiuses, 6.28 of them as well. It's always 6.28, 2 pi copies of a radius. So that's the idea that we've been exploring. Now, perimeter, in the circle case, I'm just going to add one more piece to it. So the idea was, there's a radius length, and if I took that radius length, I could wrap it around this circle, 6 and a quarter, 6.28, let's just say it, 2 pi times. There's 2 pi copies of a radius length in that circumference length. So we just say circumference is 2 pi copies of a radius. Now, what if we knew that the radius was 2 inches? Then we could actually get probably what you would prefer, feels more comfortable to say, an actual measurement with the conventional inches. Now, I want you to be comfortable just saying 6.28 radius lengths is the circumference of a circle. That's fine. But if we were actually measuring for some practical purpose the circumference of this circle, and we knew that the radius was 2 inches. Now remember, this says there's 2 pi, 6.28, copies of a radius. So 2 inches, 2 inches, 2 inches, 2 inches, 2 inches, 2 inches, and a little more. So if there's 6.28, 2 pi, copies of 2 inches, what would that be? Well, you could grab a calculator or grab your phone and just type in 6.28 copies of times 2 inches. This circumference would be about 12.56 inches in circumference. Now, if the radius was something else, we would take 2 pi times whatever the radius was to get the circumference of this circle. All right, now, your assignment. In addition to R&Rs and friends and families and things like that, maybe a discussion question this week, I can't remember. But in addition, I have an assignment for you. The question is this: can you imagine a tennis ball can? I would like you to provide a mathematical argument, that is a justification, mathematical justification for this question. Is that tennis ball can taller or rounder? Now what I mean by that is, imagine the height of this can would be some measurement, one-dimensional. Imagine the circumference of this can would be some measurement, one-dimensional. Which of those two measurements would be the greater? Now, you can play with it. You could get out a ruler. You could go buy a tennis ball. Maybe you have it at home. I don't know. You could measure and make your argument. But I don't want that. Here's what I'm looking for. When you write up your argument, you should never, ever, ever say anything about inches or centimeters or feet or anything like that. What I would like you to do is practice thinking about measurement. And as you write up your result, you should provide evidence that you've been thinking about the elements of this module. So, you should be clear on, I measured this attribute. I used this as a comparison, and I compared multiplicatively. And remember, since we're talking about circumference, something that we learned in this module is you can use a radius length to measure things. Hint, hint. So your argument, your justification should not be about inches or feet or centimeters or anything else. It should be about something like radius length would be a good way to go. And then make an argument. Make it clear. This is bigger than this. The height or the roundness, the circumference, which one of those two is bigger? And here's my argument for why. You will see that in the next assignment.